All right, good morning, everyone. All right, so I do have a few students that have not taken the test yet. They have to do a retake of the test, so I'm not going to talk about the test today. But the class overall did very well, and so I'll talk about those results on Thursday. We only have today, and then we have Thursday, and then we do not have class on Tuesday of next week because next week is finals. And so as you can see here, today we're going to cover solving systems of linear equations and linear inequalities. And then Thursday is going to be all about review. So I will send out tomorrow, I'll email everybody a review for the final. It will be somewhat comprehensive. It'll cover topics from the whole semester, but it won't be every topic. I'll just pick out the highlights. So make sure that you check your email tomorrow, take a look at that review, and then come to class on Thursday with questions. And then again, next Tuesday, we do not have class, but we will meet on Thursday. Let me just double check that. Let's see, yeah, we have no class next Tuesday. We have class on Thursday. We'll meet in our normal Zoom session, except that it is scheduled to go from 9:30 to 12:15. I do not know. I don't think it'll take everybody that long to finish the test, but that's how much time the class is given to take the test. So I'm guessing the test will be no longer than 2 hours. But let me get the review put together, and then we'll kind of see. We'll go from there. Any questions on that? We're good. Okay, so we're going to do systems of linear equations, and let me start out with the good news here is that a lot of what we're about to do is stuff that we've done in the past, and so it'll look familiar, except we're going to add this extra layer onto it. So let's say that I give you something like this. I ask you to graph x plus y equals 6. So this is from the very beginning of the semester. You would have to recognize that what you're looking at here is a linear equation. And that means when you graph this, this should be a line. And there were two ways that we went about doing this. One way was using the intercept method, and the other way was by turning it into the form y equals mx plus b. So let me write that down. You have two approaches here. The first approach is the intercept method. And then the second approach is to make it look like y equals mx plus b. So I'm going to just look at this equation right now. I'm going to choose to solve this for y. So I'm going to subtract x from both sides. And I'll get y is equal to negative x plus 6. And now I just have to identify, what's m and what's b. So for me, I have a negative 1 in front of the x. So negative 1 is the m, which is the slope of the line. And then this number right here, positive 6, that's my b. And hopefully you remember how to do this. Let me change my graph to graph paper here. What you would do now is you would come over here and draw this line. So you would start, let's see, you start at the y-intercept of 6. So I go up 6, 1, 2, 3, 4, 5, 6. I put a point, and then my slope is negative 1. And negative 1, I have to write it as a fraction, so I put negative 1 over 1. So this is my rise over my run. And so I'm going to rise by negative 1, which actually means go down 1. And then I'm going to run by 1, which means go to the right 1. So from that point that I just put, I'm going to go down 1 to the right 1. And I could do it again if I wanted to get another point. Down 1, right 1. Down 1, right 1. And I'm going to draw a straight line through there. Okay, so that's nothing new, right? We've done that before. So what we're going to do today is I'm not going to give you one line to graph. I'm going to give you two lines. So here's another line. Okay, the other line I want us to graph is negative x plus 2y equals 9. And for this one, I think what I'll do is I'll do the intercept method on this one, just to remind you of the two differences. So if we do the intercept method to graph this, then I'm going to first find the x-intercept. Does anyone remember how to find the x-intercept? No, it's been a while. Set y equal to 0 and then solve for x. Okay, so I'm going to take the equation, I'm going to replace y with 0. And that basically kills off that piece, and we just get negative x equals 9. And now what I would do is divide both sides by -1 to get positive x there. So I get x is equal to -9. So that's where my x-intercept is. And then I find my y-intercept, and to do the y-intercept, I set x equal to 0 and solve for y. And if you go back and look at when we did this, on the test, I let you choose. You could graph whichever way you wanted to. Didn't matter which method you used. So if I plug in 0 for x, it goes away. I get 2y equals 9. And if I divide both sides by 2, I get 4.5. So that means that to draw this line, I'm going to have first an x-intercept of -9. So I'm going to put a dot at -9 on the x-axis. 1, 2, 3, 4, 5, 6, 7, 8, 9. Here's -9 over here. Put a dot there. And then my y-intercept, I have 4.5. So I'm going to go up. Let's see, 1, 2, 3, 4. 4.5 is about right there. And I'm going to draw that line. I'm probably not going to do a very good job of drawing this line. Let me see. Let me try this. That's not bad. Okay, so what I just did is nothing new. If I give you a line, you should be able to graph it, right? But today is about what we call solving a system of linear equations. So what we mean by a system of linear equations is I'm not asking for you to solve this equation. Well, let me back up. Remember that whenever we graph a line, every single point on this line, every one of them represents a solution to that equation, right? Every one of those. And then every point on the red line is a solution to this equation, all right? So there's an x and a y there's a bunch of x's and y's that you could plug in to make this true. Like, for example, 3 + 3 would be 6. And if I look at my graph, that point right there is the point 3, 3. And then what else could I do? Maybe 4, 2. 4 + 2 is 6. So that's this point right here. That's the point 4, 2. So there's an infinite number of answers for the first equation. And there are an infinite number of answers for the second equation. But there's only one answer that's a solution to both equations at the same time. Can y'all tell where that is on the graph? Can y'all tell which point would be an x and a y that would be a solution to both of these simultaneously? Anyone have a guess where it is?
1, 5.
Okay, so what is that point? It is the point 1, 5, but visually, what is it? It's where these two lines what?
Intersect.
Where they intersect, right? So it's where these two lines hit each other, right? that solution, you can tell by looking, I think that's the 0.15. Let's just check. If I plug 1 in here and 5 in here, 1 plus 5 is 6, that's true. Now what would happen if I plug 1 and 5 in here? Let me try that. If I plug 1 in there, I get -1 for x plus 2 times 5. Does that equal 9? Well, that's -1 plus 10. Yes, that equals 9, right? That's the same as taking 1 away from 10, so that works. But that point right there is the only point that is a solution to both at the same time. So that's what we're interested in, okay? At least to start today, is if I give you two lines, can you find their point of intersection? Can you find the solution to both equations at the same time? So the way that I would write this, okay, if this were a brand new problem, here's what I would tell you. I would say solve, and then I would do this. I would put a brace like this, and then I would write the two equations down. Like that. So if I write something like this, using this notation with the two lines and then the big brace in front of it, this is called a system of linear equations. Now, to give you some idea of where this might be useful in the real world, I'll just give you just the first thing that comes off the top of my head. Let's say that you have a graph, and let's say that this is, I don't know, time, and this is money. Okay, so you have a job, right? So you know that you make a certain amount of money. You're an hourly employee. You can make a graph that shows how much money you're bringing in. Okay, so maybe this is your income. But then you have an apartment, you have car payments, you have money going out. Okay, so this would be your out expenses. Then what would this point here represent, where those two hit each other? Well, we call that, there's a name for that. That's called the break-even point. And it's the point at which your income and expenses are equal to one another. They're the same, okay? So that would, if you were able to find that point, you would actually be able to determine like what point in time your income is going to be more than your expenses. Do y'all see your income is above this one? So if you get past this point in red, then you know that you're bringing in more money than you're spending. If you're to the left of this point, then you're spending more than you're bringing in. Does that make sense? So like in the real world, break-even points are useful because you can project out in time, like, hey, I need to at least get to this point in order to make money. Okay, so that's just a real generic example. I just want to give you something that you could kind of think about. All right, so let's see, how would we solve this? I mean, we did it visually here. We drew the graphs, right? We drew these graphs and we could tell, well, I don't know, I'm not sure who said it, but someone said 1.5. And that's because you could tell, because my picture was pretty decent. The question is, can we find that 0.15 without any graphs, without drawing anything? All right, and that's what the goal is. So let's start with this problem. I'm going to get rid of this picture because I don't need it. And let's try and solve this system of linear equations. Now, there are two methods to solve a system of linear equations. All right, there's two methods. And I don't care which one you use. All right. The first method is called substitution. And the second method is called elimination. Now, students seem to, I don't know, they seem to pick one of these and they're like, that's the one I want. I'm always going to use that one. I would suggest that you remain open to the idea of using both, because sometimes substitution is easier than elimination, and sometimes elimination is easier than substitution. So I'm going to show you both methods now. Okay, so here's the first method, substitution. Now, if I write the steps down, I think it gets confusing, because the steps, if I write them, it just, I don't know. I think it's better if I just work through it. And then once you see a few examples, you'll kind of hopefully catch on to what we're doing. All right. So what we're going to do, we're going to look for substitution. Sorry, substitution, not substitutions. We're going to look at both equations. Okay. I have two equations here, the one in yellow, the one in green. And I'm going to ask myself, excuse me, because I haven't talked much lately. I'm going to ask myself, which one of those equations is easier to solve for y? So what do you think? Look at those two equations. Which one would you rather solve for y? The yellow one or the green one?
Yellow.
The yellow one, right? Because it already has y, right? This one has a 2y. So if I try and solve for y here, I'm going to have to divide by 2 at some point. I don't feel like dividing by 2. Here, I just move the x to the other side, okay? So I'm going to take the first equation. Okay, I'm going to kind of write down what I'm doing here. I'm going to take the first equation, and I'm going to solve it for y. Okay, let's do that. So I've already done it. I already did it earlier, but hopefully you'll agree that it's this. Right, because all we're doing is subtracting x on both sides. Any questions on that? No? Now, once you do that, now comes the substitution step. This is why they call it substitution. Now what we're going to do is we're going to substitute that answer we just got into the second equation. So what that means is I'm going to write my second equation down. Let me write my second equation down. But instead of writing y, okay, see how that second equation has a y in it? Instead of writing y, I'm going to replace that y with what I just said y has to be. And we said y has to be negative x plus 6. So in parentheses, next to that 2, I'm going to put negative x plus 6. And then I complete the equation equals 9. So this is the second equation with the y replaced or substituted with this expression for y. Are there any questions on that? Sure. Okay, now at this point, notice that your equation that you're looking at only has one variable in it. It only has an x. So now what we're going to do is we're going to solve for x. Okay, so to do this, I'm going to have to distribute this 2 through the parentheses. So that gives me a negative x out front. Be careful, that 2 multiplies through and hits that negative x, becomes negative 2x. Then the 2 hits the 6 and becomes a 12. And that equals 9. I'm going to have to finish this up over here. So now I can put these x's together. Negative x, take away another 2x, that's negative 3x, plus 12 equals 9. And now it's just a nice little linear equation. Let's get x by itself. So I will subtract 12 on both sides. If I do that, I'm left with negative 3x on the left. On the right, if I have 9 and I take away 12, that gives me negative 3. And then the last step here would be to divide both sides. Divide, right, not add. Divide both sides by negative 3. And that gives me x is equal to, let's see, negative 3 divided by negative 3 is positive 1. So now I know what x is. And didn't we say earlier when we were doing this, didn't we say that the answer would be 1, 5. So we actually got just now, we got that the x has to be 1, right? That checks with what we did earlier. But we still need to figure out, we need to figure out what y is. So this is the last step. Now what we do is we substitute that answer, x equals 1, into the first equation that we had here, which I'll highlight in blue. This equation right here. Remember when we solved for y, the very first step? We're going to take that answer, x equals 1, and substitute it back into that one. So y equals -1, because we just got 1 is x plus 6, and -1 plus 6 is 5. So y equals 5. So if I were to write my answer as a point, if my x is 1 and my y is 5, then there's my answer. Any questions?
How did you get -1?
Where? Oh, right here?
Yeah.
Right there. Okay, so I'm substituting it back into this blue equation right here, right? And do you see that in the blue equation it says -x?
Okay, yeah.
So that negative went in front of x, but x was 1, right? So it became -1.
Okay.
That's good question. Any other questions? So the substitution method, let's just kind of go through it again. You're going to look at the equations. You're going to say, which one would I rather solve for y? You pick that equation, you solve it for y. Then you rewrite the other equation, and you replace the y with what you just got when you solved for y. You take that equation, solve it for x. Once you figure out what x is, you substitute that back into what you got on that first equation when you solved it for y. I realize that is confusing, but do you see why me writing the steps down would be weird? Because I mean, I would have to say like, okay, go pick this. So I think once you go through a couple of these, you just kind of catch on to it. Now, let's do the same problem with elimination. All right, that's the other method. And it's a completely different method. So you really have to make a choice, like which one do you want to do? And I always tell my students, like, don't get married to either one of these, right? Like, don't commit yourself to one over the other. Always be open to both. Okay, so here's how elimination works. Okay, so with elimination, what you're going to do, and let me get rid of the colors here if I can. Let's see if I can get rid of these colors. Okay, with elimination, what you're going to do is you're going to look at your two equations and you're going to look at your x's first, okay? And ask yourself, what would happen if you added these two together? So if I did x and I added -x, what would happen if I did x plus -x?
It would cancel out.
Cancel, wouldn't they? So you're looking at them and you're asking yourself, if I add these together, will they cancel? And if you get lucky, they will, okay? Like in this case, do y'all see that these x's are just going to go away? Yes? Now, in the next example, that's not going to happen, but you'll see elimination will still work. We'll have to do something first, but you look at these x's and you ask yourself, will they cancel if I add them together? And let's say they didn't cancel, okay? Let's say they didn't. Let's say that this was 2x minus x. Then if you add those, it wouldn't cancel, right? Then what you would do is you would look at the y's and see if you add those together, would they cancel? So if I add these y's together, would they cancel or no? No, right? Y plus 2y is 3y, so they don't cancel, but the x's do, all right? So what I'm gonna do here is I'm going to add these two equations down. Since the x's cancel, so I'm gonna kind of jot this down. Since the x's cancel, I'm going to add the equations. So what I mean by that is I'm gonna take x plus y equals 6. And then the other equation, negative x plus 2y equals 9. I'm just going to add them straight down. So if I add down, when I add down, these x's cancel, so I get 0 plus, and when I add these y's together, I get 3y. And don't forget, you have to add the other side. So equals 9 plus 6, that's 15. And holy crap, look at this. This just says 3y is 15, right? And now just divide both sides by 3, and you get y is 5. Didn't we say y was 5? And we got that really fast, didn't we? Like that was a lot less work. Now we still need to find out what x is, right? We still need to find out what x is. So how do we find the x? What you do now is you'll take this answer and we will substitute it into either of the equations that we started with. So you get to pick. Go back to the original problem. You pick. You can either pick the top one or the bottom here and just plug y. We're just going to replace the y with 5. So I'm just going to take the top equation, okay, which was x plus y is 6. And I'm going to replace y with 5. And then I'm just going to subtract 5 on both sides. And you get x is 1. Bam, we're done. That's pretty nice, right? Wasn't that? I mean, I just personally, I think that that was a little bit easier than doing all this, right? Solve one of these for y, replace it into the other one, solve that for x, take that answer, substitute it back into the original one. This one, we just added straight down, boom, y fell out right away. We take that y, we plug it back into either one of these, and we get 1. Just so you see, if you don't believe this is true, we could have used this one instead. Negative x plus 2 times, so we already know y is 5, so 2 times 5 equals 9. This would have given us negative x plus 10 is 9. Subtract 10 on both sides. You got negative x equals negative 1. And then divide both sides by negative 1, and you get x is 1. So you would have got it both ways. The first equation seemed easier. Okay, we good? Any questions? Let's do another one, a whole new problem. Okay, the next problem is going to be this system of equations. Let's see, 2x minus y equals 10, and then 6x plus y equals negative 2. Okay, you have 2 options, right? You have 2 options to solve this. You can use substitution or elimination. So would somebody like to tell me which way they would like to do it and maybe why they'd like to do it that way?
Elimination.
Okay, so why do you want to do elimination?
The y's are equal value.
Yeah, so look, if we do substitution, we would have to solve one of these for y, right? Which I could solve, maybe the second one for y would be pretty easy, just move the 6x over. But I have negative y here, and I have positive y here. So I recognize, Jesus recognized that these are opposites, right? And so if I add them down, they'll go away. I think that's definitely the way to go. So let's go with elimination. Anyone have a question on that? Like why we're choosing elimination? So let's add these down. Okay, when I add the x's down, I get 8x. The y's go away, so plus nothing equals 8. 10 minus 2, right? And now I get 8x equals 8. And just divide both sides by 8, and x is 1. And that really came out fast, didn't it? X is 1. Now I'm going to take that and I'm going to plug that in to which equation? Which equation would you like to replace the x with 1? Doesn't matter which one you use. Any preference? First one, second one?
First one?
Which one, Carolyn?
The first one?
Let's do the first one. Okay, so we're going to take the first equation, which is this one, and we're going to replace the x with 1. Okay, 2 times 1 minus y equals 10. And that gives me 2 minus y equals 10. Okay, we need to get y by itself here. So how about subtracting 2 on both sides? That leaves you with negative y equals 8, because 10 minus 2 is 8. And now we have to divide both sides by negative 1 to get rid of the negative in front of the y. So y is negative 8. So as a point, it should be the point 1, negative 8. I like that. That worked. I personally like elimination. I personally like elimination seems to, well, later on in math, we actually do systems of equations where we have 3 equations and we have 3 variables instead of 2. We have x, y, and z. And anytime you get to three equations and 3 variables, substitution no longer works. So you have to use elimination. And so elimination is always just like the more powerful method. But, you know, whatever. There's 2 methods. We teach them both for these systems. So just to show you what we just did. Okay, the problem we just did was this line. This line right here is 2x minus y equals 10. And the other line was 6x plus y equals negative 2. And we found that point of intersection right there. You can see from the graph, if I hover over that, they hit each other at 1, negative 8. And that's what we just determined. But we didn't need the picture to do it, right? We did it all by hand algebraically. Taylor, it looks like your dog is very interested in this.
No, she came out of nowhere.
No, she likes the math. It's okay. It's all right. Okay, so any questions there? We're gonna do one more, and we're gonna kind of run into a little problem here. All right, so here's the next one. And this is actually going to be our last example. And then we're going to do one more thing that we still haven't discussed yet here with this. So 2x minus 3y equals 5. And then 4x plus 2y equals 10. All right. So our instructions here are to solve this. All right, so if we think substitution, right? I personally do not want to solve either one of these for y. And the reason I don't is because this one has a negative 3 in front, so I don't feel like dividing by 3. I'm going to wind up getting fractions. And here this has a 2 in front of it, so I don't feel like dividing by 2. So substitution is not something that I'm really leaning towards right now. I'm thinking more elimination. But what's the problem with elimination?
There's
you have
nothing that cancels out right now.
Yeah, there's nothing that goes away, right? If I add down, these x's won't go away. 2x and 4x, that's 6x. Negative 3y and 2y, that's negative y. It didn't go away, right? It's not completely gone. So what do we do here? There's an easy way to fix things. Remember, anytime you have an equation, okay? So let me just write this. I'm just going to write the first equation, for example. Just remember this very important property of equations. Anytime you have an equation, you can always multiply both sides of the equation by anything you want, other than 0. You can't multiply the equation by 0, or else it makes 0 equals 0 and everything goes away. But if I wanted to, I could take this equation, I can multiply the left side by 5 and the right side by 5. If I didn't want to do 5, I could do -1 and -1. I could pick any number, okay, 7 and 7. I can do that to any equation, right? Multiply both sides, and it still maintains the equality because it's like a balance, right? Whatever you do to one side, you do to the other, everything still the same. So I'm going to use that property, and I'm going to be very clever, and I'm going to try and make the x's cancel. Okay, so if this one is 4x, then wouldn't it be really nice if this one up here was negative 4x? Wouldn't that be nice? Because if this was negative 4x, then the 4x's would cancel. So I'm going to make it negative 4x by doing this. I'm going to write a -2 on the outside here and circle it. That's just letting me know and everyone else know that I'm about to multiply the top equation, just the top equation, by -2. So this -2 is going to go through to everything. So it becomes negative 4x. Negative times negative is positive, so positive 6y equals -10. Are there any questions on what I did there? Multiply the whole top equation by -2, right? And now my second equation, I didn't touch it. I just left it alone. Is that right? Yeah, that is right. Okay. All right, so now do you see that the x's will cancel if I add straight down now? So let's go ahead and add straight down. And this time I'm not even gonna like rewrite it. I'm just underneath this, I'm just gonna add down. Okay, add everything down, I get 0, and then here I get, what, 8y, and then equals, -10 plus 10, that's 0. So you get 8y is 0. And what does that mean y has to be? If 8 times some number is 0, what does that number have to be?
0.
0, right? Now you could also, if you're not happy with that, you could just divide by 8. And you get y equals 0 divided by 8 is just 0. So you get y is 0. Okay, we know what y is then. Now what we do is we go find x. So I'm going to take this y and I'm going to plug it into something. Which equation would you like to use? We can use any of these. We can use that one or that one. We could even use that one or that one. Any of those we can use. It's totally up to you. So any preference here?
Second one.
Second one? Okay, so I'm gonna use this one right here. Okay. So I'm gonna write 4x plus 2 times y, but we just said y was 0, equals 10. That kills off, we get 4x equals 10. And if we divide both sides by 4, we get 10 divided by 4, which is equal to 2.5. We have a decimal. Okay, no big deal. 2.50 is the point. Questions? I'll show you the picture of this, okay? What we just did. Here's the graph of the first line. Here's the graph of the second line. And they hit each other right here. And if I hover over the point, you can see it's point 2.50. So we found that solution that solves both equations simultaneously. All right, we good? All right, just to show you, I'd like to show you this problem. Well, you know what? I'm going to make one up. I lied to you. I'm going to do one more. Just going to make one up out of the blue here. All right. 2x plus 3y equals 20. And then 3x minus 4y equals -10. Now I can already tell you, since I'm making this problem up on the fly, we're probably going to get weird decimal answers. So have your calculator ready here. Would you agree that neither one of these look like something you want to do substitution on, solve for y? Doesn't look good? Okay. So let's see the x's here. If we add the x's, they don't go away. If we add the y's, they don't go away, right? So maybe we can do what we did before, but see, in the previous problem, it was kind of easy because what we did was we said, okay, to get the x's to go away, I just need this top one to be negative 4x, so it'll cancel this one off, right? So I just multiplied by negative 2. Do y'all see that that's not as easy here? Because this is 3x, how can you make that negative 3x? And you can't add or subtract, you have to multiply. Do y'all see the difference in this? It's not as clean and clear cut.
So I have a question.
Yeah.
Can you just manipulate both the equations like how you did in the first one instead of just doing one? Like multiply both equations so they can cancel out.
Okay, yeah, exactly. That's exactly what we're going to do, Patrick. So I think what you're suggesting is, why don't we adjust this one, multiply this one by something and this one by something, like both of them, right? Is that what you're saying?
Yes.
Okay, so what would you multiply it by?
Well, since like the GTF between the both of them, or like the closest one would be 6, so I would multiply the first one by 3.
Okay, so let me slow down. You're doing it right. This is correct. So see, everyone, what Patrick's realizing, he's looking at the 2 and the 3 here, and he's saying that the least common multiple of those two numbers is 6. That's a multiple of both of these numbers, the number 6. So Patrick's saying, I'm going to make this first one a 6x by multiplying it by 3. So that 3 is going to multiply through. Okay, Patrick, I'm with you. What are you going to have to multiply the second equation by, though?
Negative 2.
Negative 2. Good. Negative 2. And the reason why here is because if this 3 hits this, it becomes positive 6x. And if you multiply this one by negative 2, it becomes negative 6x. So you need them to be opposite in sign so that when you add them, it goes away. Perfect. Good job. That's it right there. So now what we do, don't forget, we have to distribute the 3 through everything, and then we have to distribute the negative 2 through everything. Don't forget, it's got to go through the whole thing. So this will become 6x plus 9y equals 60. And then the other one will become negative 6x. And then the second multiplication should give me plus 8y. And then the third multiplication should give me, what's that, 20, positive 20? Any questions there? Add straight down. Nothing. 17y equals 80. 60 plus 20. So 17y equals 80. And see, this is what I told you, you're going to need your calculator. Divide both sides by 17. So 80 divided by 17. Yeah. Y is approximately 4. I'm going to say 4.71. I'm just going to round it 2 decimal places. That's what Y is. Now, how do we get X? What are we going to do? Take this
Substitute
Y
with the
and,
x's.
yeah, plug it in, right? Which one though? Which equation? It's up to you, really. I don't know. I mean, I like to always go back to like I never like to mess with these because these are usually more complicated looking. I just go back to one of these and I'll just grab the first one. Okay, I'm going to replace the Y in that equation with 4.71. And then I'm going to go try and solve for X. So I have to multiply this times this. So again, I'll need my calculator, 4.71 times 3. This becomes 2x plus 14.13 equals 20. I'm trying to solve for X, so let me get this term by itself. So I will subtract 14.13. So this should give me 2x on the left side because those go away, equals, I'm getting here 5.87. Final step, divide by 2. X is About 2.94. So as a point, it's 2.94 and then 4.71. Well, what do you think? Huh? Let's check our answer. I'm going to come over here to this program. Let me see, 2x plus 3y equals 20. And then 3x minus 4y equals negative 10. Turn the other ones off. Okay, these are our two lines right here. These are our two lines. And where did we say they hit each other? Right there at that point. Let's see, this should be able to find it. 2.941 and 4.706. Is that what we had? Yeah, pretty close. We have a little bit of a rounding issue, but we were able to do it. All right, are there any questions on what we're doing here? No, you sure? Okay, I wanna bring up one thing here. Give me a moment. Where is it? There it is. There we go. Trying to get the packet opened up here. $71. Okay. So I'm looking out of the packet here, and I'm going to look at homework here. So the homework here, it's page 177. The only problems I want you to do are problems 2, 5, 7, 8, and 9. 2, 5, 7, 8, 9. Let me write that down for you. It's page 177, 2, 5, 7, 8, and 9. Double check that. 2, 5, 7, 8, 9. Yep. Okay, and then what we're going to do is together right now, we're going to see if we can do a couple of these problems. All right, so let me see. Let's take this one right here. We're going to do a word problem. Okay, you ready? Tim Duncan. We all know who Tim Duncan is, and if you don't, then you shouldn't be here. Okay. Tim Duncan of the San Antonio Spurs once scored 36 points on 22 shots in an NBA game, shooting only 2 points in free throws. Okay, so that's hopefully you have to know a little bit about basketball here. If you don't, then I guess this might be a little confusing, but he's only shooting 2-pointers and free throws. So he can only get 2 points at one time or 1 point. He can't shoot, he's not shooting 3-pointers. All right, so hopefully that is okay with you. So the question is, how many of each type shot did he make? All right, now believe it or not, this is a system of linear equations. All right, that's what it's going to wind up being. So I always start these problems by looking at what they want to know. How many of each type shot did he make? So that they want to know basically two things. How many 2-point shots did he make? And then how many 1-point shots did he make? Or free throws, those are the same thing. Right, isn't that the two questions they are asking here? Is that clear to everybody in the question that that's what they want? They want to know how many 2-point shots he made and how many 1-point shots he made? Yes? So if there's two things that we need to figure out here, why don't we call this X and call that Y? Right? X is the number of 2-point shots he makes, and Y is the number of 1-point shots he makes. Now, if that's the case, can somebody tell me what one equation I could set up as? There's something very important about these two numbers here. He scored 36 points and it took him 22 shots to do it. Uh-oh. Yeah, can somebody tell me? How about the 22? He took 22 shots, right? How many 2-pointers did he take? How many 2-point shots did he take? Do we know? We don't, but what are we calling it?
X.
X, okay. How many 1-point shots did he take? Well, we don't know, right? But we're calling it Y. But shouldn't the number of 2-point shots he took and the number of 1-point shots he took add up to be what? What number?
36.
How many shots did he take? How many shots did he take?
22.
He took 22 shots. So look at that equation and see if this makes sense. The number of 2-point shots he took, right, X, plus the number of 1-point shots he took, Y, should be equal to the total number of shots that he took, which is 22. You all agree with that? That's one equation. What's the other equation? Well, he scored 36 points, right? Didn't he? He scored 36 points. So how many points did he make from shooting 2-pointers? Well, how many shots did he take? How many 2-point shots did he take? He took X, right? And how many points did he get for each shot? Each of those shots. Didn't he get 2 points for each of the X 2-point shots he took? So I put a 2 in front of the X because that's how many points he scored. He got 2 points for each 2-point shot that he took. You need to add that to the 1 point that he got for each of his 1-point shots, and that should equal 36. So you really have to think through this. This is just the total shots he took, right? And this is the total points. And what we're doing is we're taking this number 2 here in the front is coming from the fact that it's a 2-point shot. And the 1 here is coming from the fact that that's a 1-point shot. So the first one just counts how many shots, and the second equation counts how many points. Does that make sense? This is our system of equations. So I'll just write it down again. And now you have an option of solving this any way you want. So who wants to tell me how they would go about this? I like elimination if you do.
I would just multiply the first equation by negative. So that way
Negative,
it'd be negative x minus y equals negative 22, and then the y's would cancel.
okay, so you're gonna go after the y's. You're gonna try and make the y's cancel. Okay,
Mhm.
that's fine. If somebody wanted to make the x cancel, they'd have to probably multiply by -2, but you're gonna go with -1. Okay, send the -1 through and rewrite your new system. So you've got -x minus y equals -22. And then we get 2x plus y equals 36. And then add straight down. See, -x plus 2x is going to give you just x. The y's cancel. And over here, you get -22 plus 36. I think that's 14. And that's just x is 14. Once we know what x is, we can take that answer and plug it in using any equation we want. So I'm going to use the first equation. And I'm going to replace the x with 14. So 14 plus y equals 22. Subtract 14 on both sides. Y is equal to, what's that, 8? So what are we saying? How many 2-point shots did he take? Well, that's x, right? So he took 14 2-point shots. And y is the number of 1-point shots, and so that means he took 8 1-point or free throws, 1-point shots. And we can check our answer. Did he take 22 shots? If we add those up, we get 22, right? Now, did he score 36 points? Well, each of these 14 shots he took, he got 2 points for each one. That's 28 points. Here he took those 1-point shots, he got 8. And if we add those two together, we get 36. So hopefully that problem shows you kind of a way that you can use systems of equations to solve something kind of strange. We should look at another one. I'm trying to see which one of these I like. You pick, somebody pick. You look through those. Why don't you take like 2 minutes and look through those, read through them and see, and I'll just take a vote and I'll see what the class wants me to do. But take a minute to actually look at those. I'll just do a quick poll here. Number 14 would be A, 15 would be B, 16 is C, and 17 is D. So let's just see what y'all want to see. Okay, I think that that's enough for the vote. Okay, so most people want to see number 15. Okay. 60% of the class wants to see number 15. So we'll do that one. And I hate to be the bearer of bad news here, but this is probably the last problem that we're going to do this semester. Like, this is it. So I know that that's probably going to bring a tear to your eye. If you need to get some tissue or something, this would be a good time. All right, a test has 20 questions worth 100 points. All right. The test has true and false questions that are worth 3 points each, and multiple choice questions that are 11 points each. How many true and false questions are there? So this test has 2 types of questions, right? It has multiple choice and it has true and false, right? They want to know how many true and false there are, right? But it's important for us to understand that there's 2 types of questions on here, multiple choice and true and false. So let's let X be equal to the number of true false questions. Isn't that what we're looking for, though? I mean, they're asking, how many true and false questions are there? So let's call it X. That's the number of true and false questions we have on the test. But we have to have a Y in this to do a system of equations. So Y will be equal to the number of what? If X is the true and false, then Y needs to be the what?
The multiple choice.
Yeah, the multiple choice. Okay, even though they're not asking for how many multiple choice there are, we need to account for that because there's a mixture of 2 types. Now, can anybody give me the first equation we can set up?
X plus Y equals 20.
Excellent. X plus Y has to be 20. The number of true and false plus the number of multiple choice should be the total number of questions on the test, which we're told is 20, right? We have 20 questions. And so when you add those 2 together, we better get 20. Now, the harder of the 2 equations we have to come up with is the next one. So does anyone have an idea of how we can get the next equation?
Would it be 3x plus 11y equal to 100?
Perfect. Okay, very good. So the idea here is that each true and false question is worth 3 points, right? So we put a 3 in front of X. X is the number of true and false questions. And then each multiple choice question is worth 11 points. So we put 11 in front of the Y because Y is the number of multiple choice. And we know that when we add those up, they better equal the 100 points that the test is worth, right? So we actually had to use that 100 also. And that's it. Those are our equations. There's our system. All right, let's eliminate this. I told you not to get like married to one method or the other, but I think I'm making you a believer that elimination is pretty much the way to go. What would I do here? Someone tell me what I could do to make this thing eliminate out.
Could you multiply the first one by -3?
Yep, that's what I would do. -3 on the first one, and that would give me a -3x there. Boom, right there on that one. And then the rest I just have to multiply through, but that'll make our x's cancel. Good. -3x minus 3y equals -60. And then on the bottom, just rewrite it. Don't do anything. And now add straight down. The x's cancel. Let me see, is that 8y? Negative 3y plus 11y equals 40. And then divide both sides by 8, and you should get 5. Y is 5. Why is the number of multiple choice? So we know that there's 5 multiple choice questions on the test. And to get how many true and false, we're just going to take that. Let's take that first equation there. Let's replace the y with 5. Subtract 5 on both sides. X is 15. So there are 15 true and false, and there are 5 multiple choice. They only wanted to know how many true and false there were, right? But we went ahead and put down the rest. And you know what? I lied to you all. I do need to just show you one quick thing. It's not going to take long, okay? But I do need to show you one more thing. In terms of homework, though, I told you what problems to do off page 177, right? I told you which ones to do. And I noticed that I had you skip the ones with fractions. On the test, I'm just going to keep it simple. I'm not going to get fractions involved. I would suggest that you try and do all of these word problems, okay? This will appear on your final. So that's numbers 10 through 17. And we already did number 15, right? But see if you can do this, all right? Because this is, if you can do these, you'll be in good shape for the test. Okay, so the thing I wanted to show you is this. I'm going to give you 2 systems of equations real quick, and I'm going to work through them very quickly. So watch. X plus y equals 3, and negative 2x minus 2y equals negative 6. Right? There's a system. I'm going to multiply the top equation by 2. I hope you see that I'm doing that to make the x's cancel. So 2 here, 2 here, 2 here. When I do that, I get, let's see, 2x plus 2y equals 6. And then the bottom one is minus 2x minus 2y equals negative 6. And what happens when I add straight down? What do I get?
Zeros.
0 everywhere. 0 on the left side equals, and then 0 on the right side. What? This is weird, right? Something very strange happened here. And so let me show you, I'm going to show you the graph of those 2 lines, all right, just so you can see what's happening here. Take that one out of here. So here's the graph of the first one. It was x plus y equals 3, I think. I forgot already. Yeah. And then the other equation, you ready for this one? Negative 2x minus 2y equals, oh, that's not 2y. 2y equals negative 6. You ready? Here it comes. Did y'all see what happened? They're the same line. Y'all see that? They're the exact same line. So if we're asking where do they hit each other, don't they hit each other everywhere? So how do you know that? How do you know that they're the same line? Well, the reason you know that these are the same line is because your answer here is true, right? 0 equals 0. That is a true statement. So if you ever work out a system of equations and you get something true here, like if this turned out to be like 4 equals 4 or 1 equals 1, doesn't matter as long as it's true. If this is true, then what you'd say is, if you did this on a test, you could just say same line, okay? And that would be it. You just say it's the same line, which means you realize that they hit each other everywhere, okay? Now, let me show you a slight change from this. X plus y equals 3. Negative 2x minus 2y equals 4. Different problem. If we did this, we would try and eliminate the x's. So I'd multiply through by 2. I'd come up with 2x plus 2y equals 6. And the bottom one would be negative 2x minus 2y equals 4. We add straight down. The left side, everything goes away, you get 0. But on the right side, you get 10. Do you see that? And does 0 equal 10? Not today, right? So what does this mean? Let me go and graph it for you. If I change this to, what was it, 4? Oh, I need to turn it on. Here it is. Boom. Look at that. What's going on here? These lines they're not the same line now, right? But what are they? Something very special about them. They are, what do we call that?
Parallel?
They're parallel. And parallel lines don't hit each other, right? They'll never hit each other. So how do you know that these are parallel lines? Because your answer here is false. This is never true, right? 0 is never equal to 10. So this means they're parallel lines, which means there's no solution really to the equation, to the system. Okay, there's no solution. They'll never hit each other. I just want you to see that, because if you do some of the problems out of the homework, you might run into that. And if you do, just at that point, you're done. You just say, oh, it's the same line, or you can say they're parallel, depending on the two cases. All right, now I'm done. So is everyone clear on what the assignment is for homework? Yes. 14, no, 11, no, 10 through 17. I had that written down somewhere over here. What was it? There we go. And then 10 through 17. All right. Let's do this. Everybody likes bonus, right? So why don't I say that if you turn in 10 through 17 with your final exam. So next Thursday, you're going to take your test. You're going to scan your work into me. On a separate page, if you include problems 10 through 17 worked out, I will consider that to be bonus for the test. All right? But don't just give me the answers. I want to see the work. Okay, so I want to see you set up the equations and do the elimination or whatever. Bless you, Carolyn. You're on mute.
Thank you.
Okay. Any questions? Look for that review. Look for that review coming to you probably tomorrow in your email, and then we'll be here on Thursday to go over that review. All right. Everybody have a great day.
I actually do have a question to
Okay.
offer.
Yeah, what's up? Oh, you want to wait till after, or?
Yes.
Okay.
Thank you, sir. Have a good day.
You too. Thank you.
Thank you, sir.
Yep. Do you want privacy, Jesus? I can get you a breakout room.
Yeah, that works.
Okay. Anybody else that's here? You have any questions? Because I'm gonna go jump into that breakout room.
I needed to take my exam still.
Okay, yeah, that's right. Can you just hang on for a minute?
Yeah.
Okay. Okay, Alexis, are you ready?
Yes.
Okay. Let me stop this, darn it.